name is Justin. I'm working on Lattice. Lattice is part of a larger group called ZeroXPark. ZeroXPark is funding a lot of zero-knowledge research, research in Onchain Gaming, distributed networks, education and stuff. Lattice is a company that has been building on this idea called Autonomous World for a year and a half. Essentially, what we are aiming to do is to build very crazy things on Ethereum. You can stub whatever blockchain you like there, but it's based on the realization that all the smart, not all the smart people, that's a very big generalization, but a lot of effort has been spent on what I call the hardware stack of crypto, essentially anything beneath the application layer. So consensus, peer-to-peer networks, scalability, VMs, etc. And then you reach the software layer, and what you have there is only product people. And if you look at the personal computing industry, we have multiple layers of abstractions, even on the software side. We have operating systems, we have browsers, we have just a lot of work. Nobody programs bare metal, right? Just writes app that runs on CPUs. That's not the case. And essentially, I think my mic is back. Essentially, what we've seen, same with the personal computing revolution, is that the hardware people make things fast, and the software people make things easy. And the thing is, there hasn't been any good innovation on the software side of blockchain programming, basically ever. People still use the programming languages that have been created 6 years ago, specifically for Ethereum, but also for other chains. There are no frameworks, there are no operating systems running on chain. Nobody would even know what this would look like. So kind of the rabbit hole we went into, while building video games, we built Dark Forest, which is an on-chain game. We've built a bunch of others since then, and it's really hard. Hence why we're here with the Cometh people, because they've been trying to do the same thing, and everybody realizes it's really, really tricky. But it's not about the games. It's just about the fact that building big applications on-chain is really tricky. So we wanted to build virtual worlds, worlds whose rules run on the EVM and whose state is secured by Ethereum, right? Fully. Not just, hey, you have some assets on the blockchain and then everything else is just your regular old technology for overlords. No. We want everything there. We want to see what happens when you create a new kind of product, basically. Bunch of people call them Onchain games. We like that idea, but we created our own meme called Autonomous Worlds. Mainly it's because we want to say, hey, this is beyond gaming. This is about putting complex systems and giving them autonomy, essentially. So the problem, as I said, is building stuff on chain is hard. It's just to give another tangent, it's very similar to the 2000 internet boom, where you had to raise $50 million and hire 50 engineers to make a website, because you had to write your server in C++. You had nothing apart from the internet, essentially. And it was really hard to make anything. And then, there was more, and you got Ajax, and then there was the team, I don't remember how they were called, that made the thing that became Gmail, because they discovered, I can make a website that refreshes without clicking the refresh button. And all that stuff happened and gave us the internet as it is right now. But that was not because of better hardware. It's because of better abstractions. So over the last 6 months, we've been working on this project called Mud, which we describe as an engine for autonomous worlds, but basically it's an engine for anything on chain. Mud, essentially, the goal is to solve all the hard problems of building on-chain games, but you can cross the games and you can say on-chain apps. It's to say, hey, every team is reinventing the same thing beyond their features, and there has been an entire industry that has been built around those problems, like indexers, upgradability, all that stuff stems essentially from bad abstractions. And there were 3 problems we wanted to solve. The first one is state sync. Some people call that the chain client barrier. It's the idea that your blockchain has some state and your application has some state, and somehow they're never synchronized. And you have to, you have billion-dollar companies that have been built on this problem. Nobody's incentivized to solve it. Infura and Alchemy don't want it to be cheaper to sync stuff. They actually want you to make requests that cost 100 milliseconds of CPU to charge you a microcent for each of those. And it's hard. It's not easy to sync state properly. The other thing is content. Content can be seen from the perspective of a consumer product. How do you add new spaceship to Cometh? But it's really about everything. How do you make it such that the engineers build the engine and the designer build everything else? At Facebook, not most famously, but Messenger, all of Messenger is actually a massive app engine, and every screen in the Messenger app is actually made by designers. They don't code, or they code barely, because the engineers at Messenger solve the hard problems, and the engineers don't work with product managers. They just build the engine that builds Messenger. So you want to turn stuff to content. From a perspective of video game, there's that story around World of Warcraft where they spent 5 years building the engine and 1 year making the game afterwards. And all the designers had prepared everything already. They had tried on paper and in Warcraft 3 and they knew it should work, and then just put all the content at the end. The last problem, interoperability. Interoperability is kind of a meme. Everything interoperates with each other, but actually it doesn't. It's really hard. Interoperability is largely under-delivered. There's financial interoperability, but applications are mostly siloed. And the reason is it's really hard for apps to talk together. Because we have a bunch of standardized languages like, oh, do you own this thing? Yeah. And that's it. It's a very primitive language. It's a homo economicus language. We just talk about owning things. So this is a bit technical, so I won't go too much in details, but essentially if you've built smart contracts app and then you've tried to make a front end for it, this is specifically from the perspective of state synchronization. What you do is you describe like, hey, what your app is made of, you know, like a monster. You describe the same structure on your client, and then you put a function in a smart contract that says, hey, this is how I get all the monsters when my app starts. And you put an event, which is, hey, every time, as an example, the health of that monster changes, there's an event that is emitted, and I'm subscribing to it so I can change it in my app. And then you have to redo the same freaking thing every time you add a new type of stuff. And so you end up with thousands of lines of spaghetti code everywhere. So what we wanted to do is say, hey, like actually, if you just solve the problems and let you be fun, creative, novel, make good content. I can't turn all of these into verbs and design cool stuff. And so what we did is first, we said, okay, the video game industry has the same problem of designing for extremely large, complex applications, right? And one meme that emerged amongst the video game industry is this idea of ECS, Entity Component System. Turns out Apple built all of their software on the same thing. It's just not called ECS. It's called Entity Attribute Values. But many people rediscover the same thing. The idea is to say, hey, every single thing you care about is a number. And they're all unique. Like, I'm a number. This computer is a number. This board is a number. The idea of God is a number. And then the thing that gives substance to those things is components. Components are just pieces of data that are attached to those numbers. And those components do not care about the other components there. So, for example, the notion of embodying something, like the fact that this chair there is embodied and I am embodied, it's just because we both have a position component. But the position component doesn't care if I'm a chair or if I'm a person, right? So that's what a component would look like. Each entity, you know, entity 1 has a value for that component. So as an example, if this is the color component, entity 1 is blue. Entity 2 is null. It doesn't have a color. Entity 3 is green. But it doesn't care about what those things are. It just ascribes them a color. Then we have systems. The idea of systems are, there are pieces of logic that do things with components but don't care about what the thing is. So the move system can move anything that has a position. It doesn't care if it's a chair, a person, a monster, anything. As long as it doesn't move, the position component can move it. You can also operate over multiple components if you want to. But again, it's all about modularization. If you wanted to do something like a token with this idea, you would say, okay, we have a balance component where every address is a balance, and we have a transfer system that decreases a balance and increases another balance. And it doesn't care what owns the thing. Right now, like as an example, ERC20s can only give a balance to addresses, but what if you want to give balance to other tokens or like other things? And people make monstrous solutions in order to do this, but you should just modularize the stuff, just like allow the system, not the system. I don't want to call two different things the system, but allow the app to ascribe a balance to anything, right? And then the way we synchronize things, so here folks might have used things like the graph, indexers, blah, blah, blah. The problem with those is you have to teach them how to understand your application. You have to write a subgraph, you have to write code. Here, the way it works is every component, every time one of their key value change, they just talk to the world, which is the central contract, and they say, hey, an update has occurred. That contract just emits a stream of event that the client can read. And now the client can reconstruct the entire state. The client can just listen to a single byte and be like, I know how everything is changing in my application. And the way you synchronize them is you define some components in your contracts, you define the same one in your client, and then they're magically linked together. You don't have to write any code that connects those two things together. The state on the client is going to magically reflect the state on the contract. You can also have an indexer there. The nice thing is you don't have to write code when you use a mod indexer. There is no subgraph. You just boot a program, and then it knows about your whole application. And it's in a Postgres database, and that's it. And you can just ask it any question you want because it understands how your app has been written. You don't have to tell it how you did it. And then the way you make stuff is literally you just connect the components together. So like a fighter in a game or in this equally applies to any kind of applications, but maybe it's just a thing with health, attack, and movable. And the contract doesn't care if it's a fighter, it just knows that it's a thing that has those stuff. I want a dragon, cool, like make a new entity and bump the number up. You want to make a defense tower, remove the movable components. You create a new component, the healing component, cool, now you can make more stuff. So it's all about modularizing your logic and your state. And this also kind of like tangentially makes interoperability way easier, because when you want to connect those words together and make them talk, they need interfaces to understand each other, right? And mod is kind of an interface for everything on chain, as opposed to just specific things. So if we take as a case study ERC 721, which is an interface for non-fungible ownership, the only two questions you can ask is what's the balance of this address and what's the owner of this token? But you can't make complex questions like, hey, what are like how many people own something with that stuff, as an example? You can't make those questions. It's impossible. And so the thing we do with mod is every mod app, you can send a query to it. You can be like, hey, can you give me all the entities whose owner is XYZ and that have the attack component, the movable component? And you just send that query and you get a bunch of stuff back. So it's genre agnostic. That's where I copied the slides from a presentation we made when people were mainly using it to make games. No, people use it to make everything, but it's basically you can make anything. So to prove that, we built Minecraft on the blockchain. Everything runs on Ethereum. We built a strategy game with mod, and they're very different games, different applications. Skystrife is a real-time strategy game inspired by sorry, my computer is progressively falling to the left. I have to rescue it. Skystrife is very inspired by what's this Nintendo game? No, I'm blanking. Advance War, yes. Advance War, it's made out of 39 components, 22 systems, and 0 networking code. When we wrote Skystrife, we found bugs in the networking code, but when we solved it solved them for everybody else. And we didn't have to spend time on like, oh, what's the indexer? How do I synchronize the state? How do you do the X or the Y? The way you write Skystrife is the application thinks it's basically a local application. It has a little database in your browser that knows everything about your app, and you just interact with that. Same thing with OpCraft. We built it with Optimism. I was the two companies building that together. 8 components, 7 systems, 0 networking code. And it's basically very similar, right? Like you make a golem in Skystrife, you just put a bunch of components together. You make a block of grass in OpCraft, you just put a bunch of components together. It's just the way you represent it that actually matters and what the rules are. So yeah, that's what you get with mod. You get state sync, adding content is easy, interoperability is on steroid, and your problems are solved. I mean, now you have your real problem, which is to make a good product instead of fighting like shitty tech stuff that like takes you like 2 years and $10 million. Anyway. That's why people need a lot of money these days. You know, first they have to solve all the crap problems. So I want to talk to you a little bit about OpCraft. That's OpCraft. That's me, my friend, trying to make a house. That's running on the blockchain. So let's give some disclaimers here. So the positioning, like the fact that my friend is just moving around and looking at me, that's a peer-to-peer network. That's not secured by Ethereum, but it doesn't matter. All the blocks, all the crafting, the procedural fully all of that is fully on chain. You can see actually on the top. The video is paused now, but you can see +2, -1. That's literally a block explorer. You can see the blocks that are broken and added in Minecraft in real time. And we had, I don't want the video to play again. We had 1.5 thousand players play, do pretty interesting stuff, all with 4 actions. They could break block, place blocks, craft things, and claim. So claim is pretty important to explain for something I want to talk about later. Basically, the way it works in OpCraft is diamonds are not used to make armors. They're made to make stuff yours. So you can put them in a chunk, which is an area of space, and now nobody but you can break blocks there and drop blocks there, unless someone puts more diamond than you. And then they wanted capitalism, sorry, and then they can take your stuff. And that's it. Those were the 4 primitives. The client was open source. People could change it. And everything was built on mod, which means that, and this is something I didn't tell you because it wasn't important yet, but in mod, it's not just the first-party developers that can add components and systems, it's anyone. Anyone can add new components and systems to a contract that is already running, because it doesn't break the rules, right? Like if, I don't know, Raf, who's in the back, adds a component that says liked by Raf in a game, and he marks a bunch of stuff at liked by Raf, well, that's fine, you know? Like everybody knows about it, but they don't care. Or maybe I care, and I change my client, and the things that are liked by Raf, they're slightly golden. But you're free to lay new meaning on top of the word. That's what we do actually here. Right? We don't need to get an agreement from God in order to play tennis or like pay money to each other and like hallucinate capitalism. Those are rules we laid down on top of the low-level rules. And they went hard with this. It was running for 10 days. It was a new technology and people did super cool stuff. So first, as you expect, people build a lot of things together. Just lots of stuff, lots of pixel arts and stuff like that. But then it became really interesting when a couple of days later, people understood how to change the game. So The first thing we saw is someone made a drill plugin to mine diamond automatically. That's what everybody does in every single video game. And then someone made a better one that mines even faster. That's peer-reviewed science and building on the shoulders of giants. Someone made a chat plugin that everybody used to talk together. Yeah, just change the graphics. But then we saw something really interesting that you can only see in a game that runs fully on-chain. Someone built the Autonomous People's Republic of OPCraft. So that's basically a communist government run on the blockchain, created by an anonymous person. And what they did is they just mined 300,000 diamonds in one night, probably with a lot of machines and a lot of bots. And then they claim every single piece of land that had stuff built on top of it around the spawn. And they were like, we declare the independence of OPCraft. In order to join the alliance, you have to install a plugin on your game that literally transfers your entire inventory to the inventory of the Republic, and in exchange you can build on top of the land controlled by the Republic, basically. And the way they did this, and this is the plugin, they even had a social credit system where you had ranks. It's inspired by some great successes out there in the world, and that's the inventory you had when you joined the Republic. You had 161,000 diamonds and a bunch of other stuff. People built monuments with that. It was really cool. Yeah, that's a monument they built. This is an idol for the the supreme leader. And here's what they did. They changed the plugin. Sorry, they changed the client and they told everybody install that plugin. And they added a new component, the comrade component, that is essentially a registry of all the comrades, and a new system called the government system that comrades can use to build as the Republic. Basically, it's almost like a proxy. And they did that without asking us anything. They didn't need to apply to be a developer. They didn't need an API key. They didn't need to I don't know, mod the game and fork it, because we've had modding before, but modding always involved making a copy of the thing and then convincing everybody to move to your copy. That's like modding on top of existing things, which I think is quite interesting. And you can imagine how doing stuff like that in a traditional game would have involved putting those social features, those literally it's basically societal infrastructure, right? How do you get the players to play together? You would imagine that they would have to put that amongst the base actions, right? And that's what every game does. They add start guild as like a thing that exists in the game, right? It's like part of the rules. And then if join guild, battle guild, blah, blah, blah. And you have to bundle all of this with the low level rules. And then what the players can do, well, they can talk about it on Discord or on forums, but they don't have much agency beyond all of this. Whereas in something like OPCraft, you can totally start layering those things on top of what already exists. The only thing that people need to agree on is the low level rules. And then everything else can emerge on top of that. Yeah, you can get all the classic hallucinations we have. Religion, money, social structures, nations, and so forth. So those are some of the little stats. We made almost 4 million transactions, 1.5 thousand players, lots of traps. I didn't show that, but people got stuck in holes all the time. There was a whole squad on Discord that was digging people out. It was pretty funny. Plugins and one supreme leader. So that was a little experiment run for 10 days, and it was interesting to see, yeah, you can build something that is akin to an existing game in 5 weeks. We had 3 engineers build this in 5 weeks. And it scales. I mean, to some extent at the end, I think you had to download a gigabyte of data to start the game. It really stress tested the whole idea, and it gave us it gave us new ideas for the V2 of the whole architecture, but it was interesting. And the last thing I want to show you today is this little game we've been working on, that we actually played with the Cometh people earlier today. So I have to juggle between 2 different presentations. Let's go. Okay. Don't ask me why people are making Figma presentations at Lattice. I don't know. So this is Skystrife. Skystrife is basically, it's like Advanced War on the blockchain. It's a cute Supercell-like Advanced War where everybody brings little units in a strategy game and they'll try to escape with the crown. And whoever escapes with the crown wins. So this is what the game looks like. I mean, this is just like I'm scrolling through a map. It's pixel art. You have to compete for the Ember Crown. You grab the Ember Crown, everybody wants to kill you, and then you escape. If you manage to escape with the crown, the game ends. There are alternative objectives. You can steal all the stuff on the map, and essentially as soon as the crown escapes, everybody ends with whatever they have in their inventory. And then you can bring your items back in other games and craft stuff and so forth, the classic. So the way it works is you make armies, you move them on a grid, and you make them fight. You can see that underneath settlements, which create armies and units, there are little yellow dots. Those are action points. So the game is neither turn by turn nor real times. Why did we do this? Well, turn by turn games are really annoying because you have to wait for everybody to finish their actions before doing yours. And that doesn't scale to many players. real-time games are unfair on the blockchains because machines are going to beat the shit out of you because they can play 1,000 times faster. So how do you make a system where people are bounded in terms of their actions, but you don't have to wait for other people to finish their turn? So the way it works is you can only do so many things with a unit, and then you have to wait for quote-unquote a new turn for all of them to get new action points. The way you progress is simple merging mechanics. You take 2 the units that are the same, you make a more powerful one. And then you have battles. People fight. And they have to place themselves at the right place, use range units in the right way, upgrade themselves, and so forth. It's pretty fun. And that's the turn-by-turn mechanism. So you can see those 3 units, they didn't have action points. Boom, the energy surge kicks in. They all have new action points. Some regenerate faster than others. You move them, they're out. Boom, you have to wait for the energy surge. So it's a mix between real-time strategy and turn by turn. I don't think anyone else has done this before. It's a weird thing we ended up with because of the constraints of the chain, but it has been interesting to balance it. And it's built with mud. It's 10,000 lines of solidity built by a single engineer because it scales really well. It's complex. It doesn't become spaghetti, basically. It's very well organized. So 43 components, 32 systems, still shipping. This is, as an example, how you define a swordsman in the game. And you can see that a swordsman is just a bunch of components attached together. The game actually doesn't know what a swordsman is. It's just, oh yeah, that's some, don't bother about the unit type. That doesn't have, it's just about telling the client, hey, if you see this blob of things, render it as a swordsman. But it doesn't matter in the logic. We could actually completely drop that. But what the swordman is it has stamina, it can fight, it can move, it can't be traversed, and then it has an inventory. And if you want to make it fly, just add flying component. Boom, now you have swordsman to fly. So actually, the nice thing is because everything is content, the whole map of the game is just a big blob of ECS data. It's not code. We have a map editor because of that. People can make their own map. So it's really pushing what you can do on chain. Actually, most of the time, people just like write very big smart contracts and that's it. They have a few constants. Here, we decided to do kind of what the people did with World of Warcraft. We made the engine. Raf wants to build a MOBA on it to see if it's fun. You can make a 1v1 game, you can change it. It's pretty flexible. And that's the nice thing with having a lot of content. You just make a game that can, actually you don't build a game, you build a thing that can express a various like area of products. I don't know what this slide was for. This is like an old presentation. But yeah, that's all I wanted to show you. I'm happy to take questions. I know this is a bit weird. You might not be used to that stuff, but I wanted to show like, hey, if you essentially stop thinking about scalability for a little bit, if you really hold in your mind that there's a Moore's law of crypto, and it's actually faster than Moore's law in terms of how much compute we can run on distributed networks and how fast it accelerates. Basically, how fast do we go from a Macintosh to a Xenon server blade? And it's a couple of years. And you can make hacks actually to go faster and like give up a bunch of security. So the idea is, okay, if the hardware is going to get way better way quickly, how are we going to manage all that abstraction and that complexity? Well, we have to build software abstractions. So I know those software abstractions come with cost. No DeFi person would build their app in mud. Oh, goddamn, they're going to pay 10 cents more every time they make a swap. But it doesn't matter when gas goes to zero, right? So we really just said, okay, we don't care about scalability. We don't care about financialization. We know like 10 people are going to want to play this game. But it's a great way to start exploring the technology. And we're starting to see more and more interest in this, and it's striking how much can be done compared to 1.5 years ago. And so that stuff is accelerating pretty fast. So yeah, thank you.